Good morning, guys. So, actually, let's not do it like that. Let's do it like this. Boom. All right. So there's a few things that I want to talk to you guys about today. We've gotten a fair amount of practice solving exponential equations. I want to get some more practice solving logarithm equations today. We haven't done a whole lot of that. And then the other thing I want to talk to you about is test 3, which is getting very close. So let's maybe talk about that first and get it out of the way. Exam 3 will be 1 week from today. It's going to be in my math lab during class time. So the exam is only going to be open during class time. You have to take it during our normal meeting time. If for some reason you can't do that, you need to reach out to me immediately and let me know so we can set up some sort of makeup or exception. So that's 11 a.m. to 12 p.m. We're also going to be use honor log. So this is going to be proctored by honor log, which is a Chrome extension. So I would suggest that you go ahead and download the Chrome browser if you don't have it yet. I know pretty much everybody does. And then go ahead and download HonorLock also, which is an extension for Chrome. It's a safe extension, I promise. I think it's like certified, whatever. Google has said, yes, this is a safe and kosher extension for our browser. And it's basically something like ProctorU. It's one of those online proctoring systems. It's a little bit cheaper than ProctorU, so the college, when they were negotiating to figure out, what the hell to do about exams with all this coronavirus stuff, they were able to secure enough funding to get HonorLock tokens for everybody who needs them. So over the next few days, I am going to write to the department and get an HonorLock token for each of you. Everybody will have their own token, and I'll send out an email and make Canvas posts explaining exactly what to do and exactly how to do it. But it won't cost you any money. If you don't have a webcam, though, it can be a crappy webcam. It can be anything. But if you don't have any webcam, message me on Canvas. There are ways to work around that. HonorLock will still work, but I need to let them know ahead of time exactly which students need that exception built in, because the default is to require a webcam. But basically what it is it's kind of a lockdown browser first, so it won't let you navigate to other pages. And then second, it is a monitoring software, and it might feel a little bit invasive, but they're an ethical company. They're not going to do anything sketchy with your information, and it's just a way to ensure or minimize the chance of folks cheating. So the narrow time duration requiring this to be done during our regular class time and the use of HonorLock are both just there to try and maintain the academic integrity. Your degrees are only as valuable as people trust they were honestly earned. So we need to maintain that. I don't think there's anything else about the exam, at least tech-wise, that's needing to be talked about. The test will cover five point 1, 5.2, 5.3, 5.4. So this was combining functions, operations with functions. So it's one-to-one functions and their inverses. So it's exponential functions, and this is logarithm functions. So I think this goes back to homework. Let me see. Is it 16 maybe? 14 through homework 21. Yeah, also 5.5 and 5.6. So these are homework 14 through 21. If you have any questions or concerns about that, of course, we can talk about it now, but if something comes up between now and then, also please send me a message on Canvas. Talk to me before the test with any issues or concerns, and that way we can make everything go as smoothly as possible. This will be the 4th test I've run since the coronavirus shutdown using these online tools. And so far, things are going pretty well. Usually there's 1 or 2 persons that run into a bit of a hiccup. Usually I'm able to get it fixed before the test starts and everybody gets through okay. But if you wait until the day of the test to download HonorLock or to try, you know, seeing if you have a webcam that you can get to work, those sort of things, then we can get into trouble. So as long as we prepare ahead of time, plan, prepare a little bit, everything will go nice and smooth. Oh, one other thing, yeah. You'll need to show work. For every problem. And you might ask, if this is in MML, how the hell are you going to do that? Well, you're going to write your work on a piece of paper. And you're going to scan either using a scanner if you have one or a scanner app on your phone. I like Cam Scanner a lot. It's been really good for Android, to Canvas. So I will post really detailed instructions on Canvas, exactly what it is you need to do and exactly when. But basically it's going to go like this. You're going to download HonorLock. I will give you an HonorLock token before the test. Then you'll go into MML using HonorLock and that HonorLock token. You'll take the test in MML, and as you're taking the test, you're going to write all your work out. As soon as you finish with the test in MML, you're going to scan that work using Cam Scanner or some similar tiny scan app on your phone and upload that scratch work to Canvas. That scratch work is how I'm going to be able to give you partial credit. So it's important, right? It's not a trivial thing. So this is the plan. All right, and this is how I've been running at my other classes so far. So good, you know, no troubles. But if you have any concerns or questions, now is a good time to ask. So is there anything that's jumping out at you guys as being worrisome or meddlesome or anything like that? There will be one more test before the final. So this is a 4-test class. Obviously, our schedule has been shat upon pretty hard by COVID-19. So the last test is likely going to be replaced by a kind of project. The last test is on just systems of equations and systems of inequalities. And so the way I'm going to do exam 4, which is the one on systems, is going to be through a take-home project type thing. The final does replace the lowest test grade. We don't usually do that in this class, but that was one of the things the college asked us to institute right away with this coronavirus crap, is a final replaces lowest grade sort of forgiveness thing. So yeah. Yeah, so technically still 2 more tests, right? Exam 3, which will be like a serious proctored test, and then exam 4, which will be a take-home. The final definitely could hurt you. Yeah, I wouldn't think of it that way. The final is still the final. The final is still worth 25% of the grade. That will be a proctored test. The final is going to be run the same way I'm describing exam 3 being run here, and it's still worth every bit as much as it was worth before. The final can replace your lowest test grade. So if you do better on the final than you did on exam 2, then I will replace your exam 2 grade with the grade you got on the final. But the final still counts just as it did in the syllabus. So it's definitely not the case that the final can't hurt us. The final is still going to be every bit as heavily weighted as it was before. Yeah, I know that would be a big relief, but this being a core class and everything, we do need to still maintain the department final. We do still need to have everything like it is. Exam 4 is usually a proctored exam, and that's going to be a take-home project type thing. So I think that is on its own fairly extra credity. I don't have other plans besides these that I've just described to you guys to kind of soften the grading mechanic in the class. I do recognize that there's room and we should soften the grading mechanic a little bit because of the way things are going. So the two ways that I intend to do that are by letting the final replace a lowest exam score, and then also by having exam 4 be a take-home, like a project thing. I think that should be enough. You know, if the rest of things have been running fairly smoothly, and the syllabus is kind of a contract. We need to stick to it as best we can. So without stepping outside what we've all agreed to, and without, like, you know, kind of throwing away academic integrity altogether, I think this is about as much as we can do. If you don't have a webcam, that's okay. Just let me know ahead of time with a Canvas message. I will talk to the honor lock people. They can write in an exception for any individual person who doesn't have a webcam, but they need to hear it from me and they need to hear it ahead of time. So if you don't have a webcam, just send me a Canvas message and I will let the honor lock people know. And that way they can write in that exception for you. So everything will still go exactly the same. From your end, it won't feel any different. It's just on my end, I have to let them know, hey, you won't be seeing video from this guy, and that's going to be okay. Any other questions about how the test is going to work? Or grades in the class? I know that this is something that we're all worrying about. Okay, then I think that's enough talk about exam 3. The other thing that I really wanted to do today was just get a little more practice solving logarithm equations. So remember, a logarithm equation is something like this. So it's an equation where your variable is stuck inside of a logarithm. And the way we solve these, we talked about it a little bit if you saw the video that I posted for Wednesday's lecture. At the end there, we talked about how to solve logarithm equations. The goal is to isolate the log term. So I want to get this piece alone, and then do whatever I need to do to undo the log to get my variable out from inside the log. So first we isolate the logarithm. We're isolating the log term because he has my variable in there, right? My goal is to get the variable on its own. And an important step along the way to doing that is to get the box that's holding my variable on its own. So here I would add 5 to both sides. 7 plus 5 is 12. And then I would divide both sides by 2. And then from here, I have a new operation, and I've mentioned it, I think, once Monday in a live lecture with you guys, and then several times in the video Wednesday. Does anybody remember how to get the x out of the log there? That's the log base 3 of x equals 6. So there's this new operation. called exponentiate. So exponentiate is the verb. We exponentiate both sides. Just like you can square both sides or take square roots on both sides, you can exponentiate on both sides. And you always exponentiate using the base of your logarithm. So here my variable is trapped inside of a base 3 logarithm. So to rescue that variable, I need to exponentiate both sides base 3. That looks like this. That means I put in the exponent of 3. Right? So the 6 goes in the exponent of 3, and I get 3 to the 6. Log base 3 of x goes in the exponent of 3, and I get 3 raised to the log base 3 of x. The reason we do that is because 3 raised to the base 3 log of x is just x. This is our useful definition of logarithms. This is our first property of logarithms, the one that we talked about when we were defining it. It's the inverse of the base 3 exponential. So the left-hand side simplifies to x. The right-hand side is 3 to the 6. I'm not sure what that is off the top of my head. It's a big number. It's 3 times 3 times 3, 6 times. 729. So this is how we solve logarithm equations. And any logarithm equation that you bump into is going to be solved this way. You're going to start with some maybe slightly big equation, and then you're going to reduce it. You're going to simplify it by isolating the log term down to something like this. So the log of your variable, or maybe some stuff involving your variable, equals a constant. Once you get to this step, you need to exponentiate both sides, and that will get your variable stuff out of the log. So let's take a second, make sure we've got this example in our notes nice and clear, because it'll be good to refer back to as you work through homework 21. Are there any questions about this example, or any questions about the notation or the operations, what we're doing, why? Let's see, yeah. Yeah, of course. Yeah, we're going to do many more. Let's just jump to that then. Let me grab one or two from your homework. Same rules for ln. Yep, same rules for ln. Just remember that ln is the base e logarithm. So let's do one of those. This is number, actually, yeah, let's just do the first one. So homework 21, problem 1. I'll bring this back. So your numbers may vary a little bit, but it asks you to graph f of x equals ln of x and g of x equals 0.6, and then use the graph to solve the equation f of x equals g of x. So I'll go ahead and graph those for you. I'll graph them by hand, and I'll graph them in the emulator. So the ln of x, his graph looks like this. He has this vertical asymptote here at x equals 0. So this is f of x equals ln of x. And then g of x is the constant function, 0.6. So this is the graph of g of x. And what I'm looking for is the x value right here where these guys touch. That's my solution. Right. Now, if you have trouble remembering what the graph of ln x looks like, you can always use your graphing calculator. So let me switch this to this. Clear. So I can type in here ln of x, this graph. Since we're focusing over here, the domain of the natural log is just positive numbers. There's nothing over here on the left. I might as well change my window settings a little bit to like -1. I'll leave that as a 10. Let's change these to -5 to 5, just to give us a better picture. Right, just like our hand-drawn picture. That's the graph of f of x. And then if I want to add in the graph of g of x, that looks like this. So we can zoom in even a little further. Let's change this x max to 5. Let's change this to -4 to 4, just to get a nice close-up picture. All right, so we're looking for that point where those two intersect. And if I play around with my trace function, it looks like, so here when x is 1.8, y is 0.59. If I take one step to the right, x is 1.87 and y is 0.62. So that goes from under to over. So if I wanted to get a little bit more precise, I can play around in my table. So maybe I'll start my x values at 1.80 and take steps of size 0.01. Oh, not window, sorry. So when I say 1.80 and steps of size 0.01, and then I can come over to my table and start hunting for a more exact solution. So remember, I'm looking for a place where y1 is 0.6. So that would be 0.600. So I want to see what's the closest, which x value gets me closest to the y value 0.06. Well, here when x is 1.82, y is 0.59884. And so I have to ask, is that closer or is this closer to 0.6? So here the error is 0.004. And here the error is 0.122. So I'd say this is closer. So using the trace and table in the calculator, the solution x appears to be about 1.83. Right? Now, the main point of this homework is to get you to a place where you can solve these equations algebraically, right? Without using the calculator, without any of this silly nonsense. So let's see how to solve this exactly. Well, we would begin with the equation, which is f of x equals g of x. F of x is the ln of x, and g of x is the constant function 0.6. So just like our last equation, where we have the log term isolated equal to a constant, in order to undo it, I need to exponentiate. And the trick is to remember which base to exponentiate. We want to pick the base that will get our variable out of this logarithm. So we need to exponentiate using the same base as the base of that logarithm. The base of the natural logarithm is e, so I'm going to exponentiate base e. And what that looks like here is e to the ln of x equals e to the 0.6. Sorry, I went back and forth from the script L to the block L. So you just put both sides in the exponent of e. That's what it means to exponentiate base e. So John asked, could we have done that more accurately if we used our delta table to be something a little bit more fine? Yeah, that's certainly true, right? So I was only looking for 2 decimal places of accuracy there, not 3 decimal places of accuracy. If the problem wanted 3 decimal places of accuracy, then I would set delta table to be 0.001. And then take steps of size 0.001 until I found what was closest to 0.6. And then earlier asked, regular logs assumed to be base 10. Yes, that's true. So if you see a log without any base listed, that is assumed to be a base 10 logarithm. And it looks like Manuel posted the 3 decimal place accuracy answer to that last problem. So the magic of what I'm about to show you here is that it will give you as many decimal places of accuracy as you like. So let's go ahead and finish this up. That's why I wanted to do this both ways. E raised to the power of ln x, that's just x. So your exact solution here is e raised to the 0.6. And if I want to see precisely what that is, do it on this one. So I'm going to use the calculator just one more time here. So e raised to the 0.6. Yeah, 1.8221188. So this answer that we got up here, this was an approximation, and it was an approximation that I found by taking step size as 0.1, which is not an especially accurate answer. It's pretty good. It's good to 1 decimal place, but if I wanted to be good to 2 or 3 or 4 decimal places, I would need to fiddle with my table settings a little bit. So if I put delta table to be 0.001, then I could look a little bit more closely, right? And then come over here to my table. Oh, why is this still not? Let's see, did I not save something? 1.8, 0.0. Okay. There we go. So now if we wanted to, we could scroll through here and find the more accurate answer, accurate to 3 or 4 decimal places. I guess here we would just be accurate to 3. Yeah, like this, right? So which one of these is closest to 0.6? We've got 0.59993. So this is off by 0.00007, whereas this guy is off by 0.00048. So definitely 8.22 is closer than 8.23, and we could have found that approximate answer in the calculator doing just what John said by changing the table settings to take smaller step sizes. But the real magic is in this work we just did here by hand, because this is the exact solution, right? The exact solution is e raised to the 0.6. And then you can ask your calculator for a decimal to however many decimal places you want. And so for my money, this is the more valuable approach. This is what we really want you guys to learn how to do in homework 21. This being the very first problem, we're just trying to warm you up to it. The way of thinking there is that if you do this in the calculator once using the table, you will appreciate how cool and fast and slick and accurate this algebra process really is. Yeah, here I can get the screen of the calculator out of the way. Oh, what the hell? Yeah, there it is. Okay. So let's take a look at something a little bit more challenging. I'll grab one more from the homework. Let's let's do something a little harder than that. No. No, there's one or two like this. Yeah, okay. So this is number 9. And again, your numbers may vary a little bit from mine. So here we want to solve base 4 log of 3x minus 2 equals -1. Yeah, okay. So here I don't have my log term is already isolated, but the inside of my logarithm is a little bit more complicated. I don't have any variables floating around over here or over here. I don't have any constants that I need to move around to get the log piece on its own. So right away, I'm ready to exponentiate. And because the logarithm I'm dealing with here is a base 4 logarithm, I'm going to exponentiate base 4. So then my original equation becomes 4 raised to the log 4 of 3x minus 2 equals 4 raised to the -1. And the magic of exponentiation is that it undoes the logarithm. So the left-hand side is just going to simplify to 3x minus 2, right? Just like the base b log of b to some stuff is just that stuff. B raised to the base b log of some stuff is just some stuff. So this left-hand side simplifies to 3x minus 2. And the right-hand side is 4 to the -1, which is 1/4. And now this is a linear equation. Just like how taking logs turns an exponential equation into a linear equation, exponentiating turns a logarithm equation into a linear equation. And linear equations are easy to solve. I can add 2 to both sides. I may want to simplify this, right? So 2 as a ratio over 4 is 8/4. So this is the same as saying 3x equals 9/4. Because 2 is 8/4, and 8/4 plus 1/4 is 9/4. And then from here, I would divide both sides by 3. And now this is one of those kind of fraction things that we talked about the very first day of this class. So one of these things that we're just going to have to get used to at some point in this class. There's no escaping it. It's the same as 9/4 times 1/3, which is the same as 3/4, right? Because 9 divided by 3 is 3. So the solution to this equation is 3/4. Questions on this example? Before we finish this section, I would like to look at a couple of application problems, a couple of word problems. So one of those is the 13th problem from homework 21. It says that the number of fish X years after 1973 is given by the equation f of x equals here, 225, 0.71. I'll bring you back to the dot cam here in just a second. The x. They want to know when, and this is in thousands, right? When will there be 94,000 fish? All right, so let's bring you back to the dot cam. There we go. Here's the problem. So that was a question. Yeah, when I tab out of the dot cam, it blocks the screen share. That's a feature that Zoom implemented after one too many professors accidentally shared parts of their screen they didn't want to share. I am more careful than that, but some people aren't, so it's a feature of the software now. When I tab over to look at the problem, it's going to block the screen share. So this is the problem. The number of fish X years after 1973, so maybe we're tracking the number of particular species of fish or something like that. Yeah, lol indeed. They tell us it's 225 times 0.871 raised to the x. And then they ask us, when will there be 94,000 fish? So the first thing I'd like to ask, is this a growing exponential or a decaying exponential? Is the number of fish over time going up or going down? Right, because the base is smaller than 1. Zach wants to see the end of the last problem. Yeah, so really quick, here was the end of the last problem. So the exponential in the problem we're looking at right now is a decaying exponential because the base is smaller than 1. Could anybody tell me what the decay factor is? Good, right, that base, that 0.871. What about the decay rate? Anybody feeling especially savvy? Want to tell me the decay rate? So these are all just fun questions I'm asking you to kind of try and get everything tied together. Not immediately related to solving problem 13, but worth asking. Careful, careful. So the decay rate doesn't come straight from the base that simply. So to find the decay rate here, what we need to do is see how far that base is from 1. Remember, our rate formula is like c times 1 plus or minus r raised to the x. So I need to know how far is this number from 1. So I would take 1 minus 0.871. And that tells me that my decay rate is 0.129, or about 12.9%. And that's 12.9% per year. So it's good to remember how to calculate those things. Those things will stay relevant. And there will almost certainly be questions on exam 3 and on the final that ask you for that sort of thing. Okay, let's go ahead and solve this problem though. So they want to know, after how long will there only be 94,000 fish? So if this is the number of fish X years after 1973 in thousands, then I need to set this equal to 94. So we need to solve the equation. 225 times 0.871 raised to the x equals 94. This is not a logarithm equation, right? My variable is not stuck inside of a logarithm here. My variable is stuck in an exponent. So this is an exponential equation. So I need to isolate the exponential term and then do whatever is necessary to undo the exponential to get my variable down. And that's going to mean taking a logarithm. But first, just like I need to get the log term alone on those previous problems, I need to get the exponential term alone on these problems before I take logs. So my first step is going to be to divide both sides by 225. So I get 0.871 raised to the x equals 94 over 225. I don't think 94 over 225 is going to simplify. 94 is divisible by 2, not by 3. It's divisible by 4, but 225 isn't divisible by 2 or 4, it's divisible by 5. So I think we'll just leave that like that. But then the really important step is the step that undoes this exponential. So the next step here is going to be to take logs. And we could take whatever base logarithm we wanted. I could take the 0.871 base logarithm of both sides, but I don't have a 0.871 base logarithm button on my calculator, and nobody really messes around with logs like that. The most natural thing to do is to take the natural log. You could also take the common log, the base 10 log. It doesn't make a difference, but here I will take the natural log of both sides. And then we're going to use the properties of logarithms to solve the resulting equation. So I took the ln, the natural log of both sides. And now one of my properties of logarithms is that if you have a log of a power like this, then the power can come down front as a multiple. So this is the same as saying x times the ln of 0.871 is equal to the ln of 94 over 225. Let me get caught up in the chat here. The problem with the 1/4 fraction. So natural log and common log, no real difference for how the problem would look. I would just write log here and log here. And then when I went to do the calculation, I would make sure to use the log button on my calculator. But the mechanics would be exactly the same. And Zach, I will bring that one with the 1/4 back up here just a little bit, yeah. So if you wanted to look at that one, try to keep both of these on the page at the same time. Here was how that problem ended. So we'll go to this step on this one. Okay. So the question was, what happens if I used a different kind of log? Here I used the ln. I took the ln of both sides of this equation in order to get this equation. If I took the log of both sides, there would be no difference here besides writing log and log and log and log. So you can use whatever base logarithm you want. Usually you'll use either the natural log or the common log. I suggest developing a preference. And my preference is to use the natural log. If for no other reason, then I have to write less shit, right? I write fewer letters. But whatever you're more comfortable with. If you're more comfortable with the common log, use that. Yeah, no harm there. Finally, to finish the equation, to finish solving here, I have to divide both sides by this constant, right? This is x times some constant equals another constant. It's a linear equation. So I write that as x equals the ln of 94 over 225 divided by this constant, which is the ln of 0.871. Now, a common mistake at this step would be to like cancel the ln's or to try and combine these using some rule for logarithms. There is no rule for logarithms that looks like this, that has a log divided by another log. So division on the outside, the only thing that even corresponds vaguely to is the change of base formula. And ln, this is definitely not multiplication, right? This is not ln times 94 over 225. This is the ln of 94 over 225. ln on its own doesn't have any meaning. It's a function, not a number, so I definitely cannot cancel those. They don't work like that. So at this point, I would just throw this into my calculator to get a decimal approximation. That is the ln of 94 divided by 225. Then make sure to close that parentheses, because this is my numerator, the ln of this ratio. Close that parentheses before you divide by the ln of 0.871. And then close that parentheses also. And what I get out is 6.3195. And remember, the x's here are measuring years since, what, 1973, right? Yeah. So what year is about 6.3 years after 1973? It looks to me like that would happen about 1/3 of the way through 1979. Okay. Questions on this guy? This is a decent problem. Thoughts, comments, anything? Okay, so if you guys are genuinely comfortable solving exponential and logarithmic equations, then we're done. We're done with chapter 5 here. We are done with the section on exponentials and logs, which is the hardest part of college algebra. So like, you know, cheers, pat yourself on the back, feel good. But also make sure you study really goddamn hard. This exam 3 is not going to be an easy exam. I will be like scaling it back a little bit from the difficulty of my normal exam 3 because it's online, because it's so weird, because everything has been so strange. But still don't expect it to be easy. You will need to solve problems like these on that test, problems like the homework problems. So I'll do my best to keep everything in the spirit of the homework and very, very similar to what you've been practicing with, which means it's crucial that you do the practice. So please work hard on these homework problems. If you're working to get caught up, then please continue to work to get caught up. So the last homework that is relevant for the test is homework 21. Homework 21 is all on solving equations with logs and exponentials. The one before that, homework 20, is all on properties of logarithms. So how to simplify log expressions, how to expand logs and contract logs using those 4 properties that you saw in the video from Wednesday. So definitely go watch the video from Wednesday if you haven't. Make sure you're getting caught up in the homework. If there's anything that you need help with or you need more time on, let me know. Oh yeah, that is a good reminder. So if you have any sort of testing accommodation, if we've talked about extra time, or if you had accommodations through one of the centers on campus, please do talk to me. Send me a Canvas message as soon as possible. I can arrange for the extra time via MML and HonorLock, but we do need to talk about it beforehand because it's not going to happen automatically. So if there's anything like that, yeah, please let me know. Canvas is fine. We can talk about it through Canvas. Okay. All right, so if you haven't seen Wednesday's lecture, please do go watch that video, and then maybe consider rewatching this one because I know a lot of this stuff is going to feel a little bit weird without that. And that is where I will stop the official lecture today. I am getting some questions in chat. If you don't mind, I'm just going to answer them here rather than typing. I teach all the math classes. So over the summer, I'm doing a calc 2 and a Calc 1. And then next fall, I think I have a pre-calc, that's MAC1140, a Calc 2 and a Calc 1. Usually I have some college algebras and then some mixture of calculus classes. Sometimes I'll do statistics, but mostly algebra and calculus. Any other questions? Alrighty then, I will go ahead and stop the recording here for today. If you guys do have anything else that you want to talk about or anything else that comes up, please send me a message on Canvas. That's still the best way to get a hold of me. And that is it. I'll see you on Monday.